Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to discuss tree of thoughts prompting in large language models. Tree of thoughts prompting provides the model with a structured prompt hierarchy or a sequence of related questions. The model's responses to earlier prompts inform the subsequent ones, leading to a coherent and in-depth generation. For complex tasks that require exploration or strategic look ahead, traditional or simple prompting techniques fall short. Yao and Long recently proposed a tree of thoughts, a framework that generalizes over chain of thought prompting and encourages the exploration over thoughts that serve as the intermediate steps for general problem solving with language models. ToT, that is a thought prompting, maintains a tree of thoughts where thoughts represent coherent language sequences that serve as the intermediate steps towards solving a problem. Now let's try to understand the ToT framework. The first one is a simple input output prompting. The second one is chain of thought prompting. The third one is self consistency with chain of thought. We have already seen chain of thought prompting and self consistency in our previous video. Today we are going to discuss about tree of thoughts. So each rectangle box represents a thought, which is a coherent language sequence that serves as an intermediate step towards the problem solving. There are four phases in tree of thoughts prompting: brainstorming, evaluation, expansion, and decision. The tree of thoughts concept is more complex and a hierarchical approach. Instead of a linear chain like a chain of thoughts prompting, just here. In chain of thoughts, I went to the store. This is the first prompt. The second prompt is I bought apples. This is a linear. So instead of a linear chain like a chain of thought prompting, ideas are organized into a tree-like structure, tree of thoughts. I went to the store and bought. So what can be the possibilities? Apples, oranges, bananas. So with each idea branching off into multiple related ideas. So this is the example which we have already discussed. So in this case, the main idea going to the store branches off into a several related ideas. Now how it's working? Given the current state of the model and the tokens generated so far, the model calculates the probability distribution of the vocabulary for the next token. In a greedy decoding, the model simply selects the token with the highest probability as the next token in the sequence. Suppose if we write the prompt the, then it will pick up the probability, the word with the highest probability. Let's say it's dog. Then it will pick up the next word which is having the highest probability, the dog has. Suppose if it picks up the nice. Now in this, which is the branch which has highest probability? Woman, the nice woman. Suppose if it picks up the car, then out of these three, drives has a highest probability, the car drives. So it's known as a it's a greedy this is known as greedy decoding. Let's read it again. In greedy decoding, the model simply selects the token with the highest probability as the next token in the sequence. In greedy decoding, at each step of generating a sequence, the model selects the token with the highest probability as the next token without considering the future consequences or exploring alternative options. This means that the model always chooses the token that appears to be the best locally without regard for how that decision might affect the overall quality of the generated sequence. Advantage of tree of thoughts prompting. Tree of thought allows for the exploration of multiple topics or subtopics in parallel. Users can pose different questions or prompts leading to a branching conversations that covers a wide range of subjects within a single interaction. With multiple branches or responses stemming from each prompt, tree of thought enables the generation of comprehensive and multifaceted responses. Users receive a wealth of information on various aspects of the topic they are interested in, enhancing their understanding. Tree of thought provides flexibility in conversational flow. allowing users to navigate between different branches based on their interests or preferences. This adaptability ensures that the conversation remains relevant and engaging, catering to the diverse users' need. By organizing responses into a structured tree-like format, Tree of Thoughts facilitates efficient exploration of complex topics. Users can easily navigate through different branches to access specific information or delve deeper into the related subtopics. The interactive and dynamic nature of Tree of Thought encourages active user participation and engagement. Users can contribute to the conversation by posing follow up questions or exploring different branches, leading to more meaningful interactions. Tree of Thought organizes the information in a structured manner, making it easier to represent and visualize the connections between different topics and subtopics. This structured representation aids in knowledge organization and retrieval, benefiting both users and models. Tree of Thought promotes learning and discovery by encouraging exploration and inquiry. Users can uncover new information, insights, and perspectives by navigating through different branches of the conversation, fostering intellectual curiosity and engagement. So, Tree of Thought offers a versatile and effective approach to conversational interaction, enabling comprehensive exploration of topics, flexible conversation flow, efficient knowledge representation, and enhanced user engagement and learning. Limitations. As the conversation branches out into multiple topics and subtopics, the conversation can become increasingly complex and difficult to navigate. Users may feel overwhelmed by the sheer volume of the information presented, leading to confusion or disengagement. With multiple branches of conversation, it can be challenging to maintain coherence and relevance across all topics and subtopics. The conversation may may go off the track, or become disjointed, making it difficult for users to follow or stay engaged. Tree of Thought requires significant computational resources to manage and process the branching conversations effectively. As the conversation expands, the computational overhead increases, potentially leading to performance issues or slowdowns, especially in real-time applications. While Tree of Thought allows for the exploration of multiple topics, it may not always delve into each subject. Due to time constraints or the complexity of the conversation, some topics may only be touched upon briefly, limiting the depth of exploration. With multiple branches of conversation, there is a risk of redundancy where similar or overlapping information is presented across different branches. This redundancy can lead to repetition and dilution of the overall conversation's value. Users can find it challenging to navigate through the branching conversation and may become confused about which branch to follow or how to proceed. This confusion can detract from the user experience and hinder effective communication. Training language models to effectively handle Tree of Thoughts conversation can be challenging. Model needs to be able to understand and respond coherently to a wide range of prompts and follow-up actions, requiring extensive training data and sophisticated algorithms. Now let's take one example. This is a prompt. I have a problem related to the productivity in remote work setting. Could you brainstorm three distinct solutions? Please consider a variety of factors such as technology, communication, and work-life balance. So we start with the first phase, that is a brainstorming phase. Let's copy this. Enter. So it has given me three different solutions. Enhanced technology integration and training, structured communication protocols, promoting work-life balance. Let's proceed further. The next prompt is evaluating the potential solutions. So I will copy this prompt also. For each of the three proposed solutions, evaluate their potential, consider their pros and cons, initial effort needed, implementation difficulty, potential challenges and expected outcomes. Assign a probability of success and confidence level to each option based on these factors. Let's copy this prompt. So this is evaluating step 2. Enter. So we are getting pros, cons, initial effort needed, implementation difficulty, potential challenges, expected outcome, probability of success, confidence level. So for each branch, we are getting pros and cons. Now let's go for the third phase. So we have completed the second phase, that is evaluating the potential solutions. Let's start the third phase, deepening the thought process. For each solution, deepen the thought process. Generate the potential scenarios, strategies for implementation, any necessary partnership or resources, and how potential obstacles might be overcome. Also consider any potential unexpected outcomes and how they might be handled. Now we will copy this one. Enter. So now we are getting the potential scenarios, strategies for implementation, necessary partnerships or resources required, overcoming the potential obstacles for each branch, for each solution. So for each alternative, the first one was enhanced technology integration and training, scenarios, implementation, partnership, obstacles. For second one, structured communication protocols, scenarios, strategies, partnerships, obstacles, promoting work-life balance. Okay, now we will go for the fourth phase, which is based on the evaluations and scenarios, rank the solutions in order of promise, provide a justification for each ranking, and offer final thoughts or consideration for each solution. So instead of in order of promise, let's introduce in order of feasibility. And let me copy this now. Enter. So which we have got the ranking. So the first one is the best one, structured communication protocols. Then second one is promoting work-life balance, and third is enhancing technology integration and training. Based on feasibility, the ranks have been given. So feasibility rank. We can also change the ranking. Okay. Change the ranking according to the market requirement. Let's say let's understand now. Okay, so now this is according to the market requirement. So this was all about tree of thoughts prompting. For more videos on prompt engineering, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.